Hello guys, my name is Anushka Thoma. Welcome to my data science series using Python here. Today in this video, we will learn about model evolution in data science. So here, the topic we will discuss is how to perform model evolution using Python, accounting for unequal error cost using Python. Now let's see how to perform model evaluation using Python. So here we have imported some useful library which is confusion matrix, classification report, accuracy score from sklearn.matrix, and this will help us to evaluate the model. And also we have import train test split that is used to split our data set into training set and test set. And also we have imported random forest classifier. What does it do? It to train our data on the train on training data using the fit method. So here we use the predict method to generate prediction for the test set. Now let's to take an example of a data. We have created a data that where there is a variable feature 1, feature 2 and target. Feature 1 and feature 2. These are storing some values, and target are also storing some values 0, 1, 0, 1, 0. Here 0 is for false or 1 is for true value. Now we have converted this into table form by using pd.data from. Under this we have written data. This means it will convert this into table form. Now we will split our data. So here x in x, which is assigned feature 1 and feature 2, that is an independent variable, and target is a dependent variable which is assigned to y. Now we will train our data. Here we have written x train, x test, y test is equal to train test split. That will split our data into training sets and test sets. And xy test size is 0.3, that is 30% of training set, test set, and 80%, sorry, 70% of test set. Here random state is equal to 42. So here then we will train our model by using random forest model. Here we have initialized random forest classifier where random state is equal to 42. Now model dot fit, we will train our data x train and y train. Now we will make prediction. We use predict method to generate prediction for text set x. And then in this line, we will evaluate our model that will improve our model performance. So here we will print accuracy by accuracy square by test by predict. Give the proportion of correct prediction. Confusion matrix. It show the count of true positive, false positive, true negative, and false negative. I here print classification report. Classification report provide precision recall and have one score for each class. Now output for this code is like here, their accuracy, which is zero point 0, confusion matrix 0, 1, 1, 0, classification report, we have precision recall and F1 score and support. So now this is our output. For example, if the confusion matrix is 0, 1 and 1, 0, it means 1 is true negative, 0 is false positive, 1 is for false negative, and 0 is for true positive. So it is our confused. This classification report will display the performance metrics for each class. Here, this code demonstrates how to account for unequal error codes in classification problem by using a custom cost function during model training and evaluation. This model is trained using a random forest classifier with a custom scoring function applied during hyperparameter tuning. Now let's see the code. Here we have imported some important libraries, sklearn.matrix, import make scorer, import random forest classifier, and also import train test split grid search CV and NumPy library. Now we will create a function, custom loss function for unequal error cost, that is defined the custom cost function. Parameters are by true and by spread. So here cost matrix is defined. Cost of false negative predicting 0 when actual is 1 is equal to 10. Cost of false positive predicting 1 when actual is 0. So here it is equal to 1. Now the function calculate the custom cost by applying the cost matrix to the confusion matrix. Second is our input data. Here this is our data input feature x, a simple data set with two columns and labeled by This is a binary classification level 0 or 1. Now we will split our data x train, x test, y train, y test. As we know, train test split our data set into training set and test set. So here data is split into training 70%, testing 30% sets. Here training set used for fitting the model and testing set used for final evaluation. Now we will do model setup, model with custom scorer. So here what we have did, we have initialized random forest classifier with parameter random state is equal to 42. Also initialize make scorer error custom course function greater is better false. Now here we have used grid search CB estimator model. Here grid search CB is used to tune the number of estimation, that is an estimator in the random forest, and the custom scorer evaluate, what does it evaluate, each model configuration during class validation. CV is equal to 3. And here grid dot fit, the best model is selected based on the custom scoring matrix. Now we will predict an model and cost evaluation. So here prediction and evaluation is the best model predict the test data, and the final cost is calculated using the custom cost function as we have written here. Now we will print display our grid.best parameter and final cost. So our best parameters is the hyperparameter tuning suggests that the best number of estimator and estimator for random forest is 50, and for the random forest and custom code function, the final cost of the prediction on the test data set is 10. Now let's see the output of this code. Here output of code is best parameter is 10 and custom code function is 11. It means our best parameter for tuning is 10 and our custom code function score is 11 using. That's it for today's video. I'll see you next video. Thank you for watching my video.